All right, people. So the next video that is in this playlist talks about the properties and changes in matter. And this is where we start to identify the difference between intensive and extensive properties. All right, an extensive property depends on the amount of matter that is present versus an intensive property that does not depend on the amount of matter. Okay, so in extensive, I think of like how much is in the exterior, what you see on the outside, like how much of volume is in a little teeny tiny water bottle versus a pool. The mass of a teeny tiny little penny versus, a truck, the amount of energy that's in a substance, the little king size, the fun sized um, Twix versus, a king size mega pack or something like that. Okay, you're going to have less calories in the small size than you will in this size. The intensive properties do not depend on the amount. So it doesn't matter if you're talking about an ice cube or an iceberg, they will both melt at the same temperature. It might take more time for the iceberg to melt, but it won't melt at a different temperature. Same thing is true for density, boiling point, specific heat. All of these properties we'll go over, and they're labeled on the periodic table that it gives you, especially when you check the other side, it tells you their different properties. All right, so that's what we're going to take a look at. We're going to take a look at different physical and chemical properties that are going to be intensive and extensive. Right, the intensive one are going to be more of the physical properties or characteristics that can be observed without changing what the substance is. So like, what is the color? Is it soluble or not? And please, star, circle, highlight this. Solubility is a physical property, which means that it can be undone. I'm not really changing what the substance is. Salt is soluble in water. That means that I can take the water out of the salt. Okay, odor, luster, hardness, density, melting, and boiling point. These are all physical characteristics that identify the difference between different substances. Physical change goes along with physical properties. That would be a change, which is weird because change usually means something new, but it doesn't actually change the identity. When you melt an ice cube, it's still H2O. It's just going to be a liquid form versus a solid form. And guess what? You can go back. So you kind of have to ask yourself, does it change the identity? Is it reversible? If you freeze water, you can melt it again. If you cut a piece of paper, it's still a piece of paper. Can you go back to the whole sheet of paper? Sure, it'd be annoying to take all the paper and mash it up and make pulp and then press it out and iron it out again. But yeah, you can go back. Okay, bending something. Here's dissolving again. Star circle, highlight that. That's probably the most common mistake that I see. Condensing is going from a gas to a liquid. That's the condensation that you see on the outside of glass in the summertime, especially if there's like ice cubes and stuff inside. The condensation is the humidity in the air. All right, all of those are physical changes. Now, when it comes to our states of matter, okay, we're going to briefly go over what you probably already know just so that it is pointed out for you. And we're going to get into these in chapter 10 in a really cool augmented reality through Google Expedition and we can use your phones and the apps on your phones so that you can see what it's like to go through solids, liquids, gases, and the plasma phase. But these physical properties really help identify what our different types of matter are. Okay, so the three common ones are solid, liquids, gases. Plasma is what you see in stars. It's what you see when you have the most amount of energy. It's literally when electrons start coming off of it and it no longer retains the properties of that substance, but it is not a television. So what is the difference between a solid, a liquid, or a gas? So you should know these by now. Solids are going to be the most dense, okay? Liquids are going to be in between, and gases are going to be the least dense. Solids have a definite shape and volume. They expand slightly with heat and cold, but they can't be compressed. You can't make a book into a short story by standing on it. That's not going to work. All right, liquids have no definite shape. They will take the shape of whatever container they are in. But they do have a definite volume. So that means that you can't condense down a liquid, which is why when you belly flop, it hurts. It slightly expands, but it cannot be compressed. And you will see that gases are going to be completely opposite of your solids. Okay, they are not equal to each other in any way. There's no definite shape, no volume. This is mainly empty space. They greatly expand. They can be compressed. They can increase in pressure. They can pop. Balloons pop when you leave them in a hot car because they're going to basically have so much energy. And then our plasma phase is when I said that physical state when your atoms are going to lose most of their electrons, and basically it kind of breaks down what the structure is. It's found in these high energy light bulbs on the surface of the sun, and literally the electrons start coming off of it, and they're going to be around the nucleus of the atom. Solids are going to have the least energy, the least amount of temperature, and your plasma is going to have the most amount of energy or temperature. Okay? So our solids, liquids, and our gases help us look at the extensive and intensive properties. There's physical properties that we're going to get into. Our next video is going to talk about our chemical properties. So stay tuned.